Let's practice our substitution strategy, and it means just that. We're going to substitute for either x or y. So that means we're going to have to create an equation where y is equal to an expression or x is equal to an expression. Let's try it with all three types of equations when we have one solution, no solutions, and all solutions. So in this one, we have y is equal to x plus 3, and y is equal to negative 2x plus 3. This is actually great because I already have the y equal to an entire term. So it really doesn't matter which one. I'm literally going to take that entire term and sub it for y. So watch what this looks like. I'm going to use the very first equation, y equals x plus 3, and I'm going to take all this and substitute it for y. So now I have negative 2x plus 3 is equal to x plus 3. Again, once I eliminate the y's, now I can solve for x. That's what I want. I want to solve for just one variable. Let's simplify this now. I'm going to, why don't we add 2x to both sides? So 3 is equal to 3x plus 3. I'm going to subtract. And I get 0 is equal to 3x. And it makes sense. The only answer, x is equal to 0. It's the only way. Now that I have my x, I can use that information to sub in for y. So I'm going to go into my next equation, y equals negative 2x plus 3. And now I'm going to substitute x equals 0. So y is equal to 3. And there's my solution, 0, 3. All right, so again, biggest takeaway when we have a substitution, you want to create two equations where either the y is equal to some expression, so y-intercept form works really well, or x is equal. And then once you have that, you're just going to take one of them, choose this one for example, and we can just sub it into the other equation. We're going to take all this and sub it into the other equation so we can solve for x. Let's see what this looks like when we have no solution. So we already know, again, this one has no solutions. So we have y equals 3x and y is equal to 3x minus 2. Again, they're both pretty easy. So I'm going to choose to take, since this one's simpler, I'm going to take this one and substitute it for y. So that's what I'm going to do. I'm going to take this and I'm going to substitute it for y. So I get 3x is equal to 3x minus 2. I'm going to move this 3x over and eliminates. So 0 is equal to negative 2. We know this means there is no solution. This is not valid. So no solution at all. What if you had tried the other way? All right, let's say you wanted to take this and put it into that equation. So I would still have the same thing. 3x minus 2 is equal to 3x. I'd have the exact same thing and the exact same problem. So it didn't even matter which one was substituted. I end up with the same equation. And if I were to try to evaluate it, I would still get an equation that is not valid, not true. So again, if you find a situation like this, then you know you have no solution. And this means that they are parallel lines. Hit pause, jot this down. And let's try when we have infinite solutions, when the lines are the same. So we have y plus 2 is equal to 2x, and y is equal to 2 times x minus 1. What I like about this one is they're both written in different forms. So when I would see a problem like this, I would probably choose substitution and say I'm going to take this and plug it in for y. All right, so I'm going to take this one here because it's already written in a way that tells me I can substitute pretty easily. So 2 times x minus 1 plus 2 is equal to 2x. Let's distribute. Combine like terms. So these two just made 0. And 2x is equal to 2x. So remember I told you if you have both of them exactly equal to each other, then I know that this is an infinite solution. Okay, so when we see this kind of like a reflection where one side is exactly equal, that means, again, no matter what I put in for x, I will always get the same answer. So when x equals 1, I get the same answer. When x equals 2, it's the same answer. So again, this means infinite solutions. Hit pause and jot this down. And now you know how to recognize your substitution if you have 0, 1, or infinite solutions to your system of equations.